Oh yeah, we got all that fancy stuff.
After that,
But I would rather you stay here, but
there's two there, and also
We got juice.
yeah,
could go
there.
down to by like this long road to
Why?
Because I don't want you to get lost here.
I'm not going to.
Okay. I get concerned about the wife because she's got memory issues. I don't want her going out to the car, but okay, go ahead.
So this is the number 5 crossbar. You can see it's placing calls right now. This was installed here in Seattle in 1958.
Okay.
Over on Mercer Island, east of us. This was a really fantastic machine, and it was like the pinnacle of electromechanical switch design.
Yeah.
Very advanced machine.
That was one of the reasons that I was hired by Bell, was they were putting these in along with the 4A system for doing the toll accounting and so forth. It worked out pretty good, and we're sitting there on the frame running tons of wires.
Yeah.
It took us, I don't know, probably 3-4 months to do all of that.
Sure, yeah. The the crossbar switch fabric is pretty incredible as well. You got these horizontals, and then a series of verticals. So this is a 200-point crossbar switch.
Yeah.
Because there's 10 horizontals and 20 verticals, which gives you 200 points. On this frame, all the verticals are customer lines. So each of these verticals is one line.
Oh, okay.
And then all the horizontals are paths out into the rest of the machine. So, any connection can be made just by operating a horizontal up or down, and then operating the associated vertical, which will then hold that connection together.
Yeah, I've got 3 crowbar switches sitting in one of my storage containers. The problem is it's out of a NC23. It's a NEC machine, and I doubt that they're the same size or anything, although they probably fit in the same type of panel.
Yeah, I'm not sure.
I don't know if you'd want something like that.
I mean, it might be cool. I don't know what they look like.
They look basically like this. The only difference would be the size.
Yeah.
And that would be the catch right there, whether it would fit or not.
Yeah, so NEC was Nippon Electric.
Yeah, I believe
Japanese.
so. Yeah.
Northern Electric, which is out of Western Electric's Canadian partner, would have worked. But I think the Japanese switches may have been a different design. I am not sure.
Yeah. Well, these things are pretty sturdy anyway, so
sure. Yep.
Okay, moving right along. Oh, what do we got here?
Oh, this is a map of the exchange area in Seattle.
See, is that focused?
I'm sorry?
I was just wondering if that's focused. I think it is.
So, we are right here in Duwamish.
Okay.
This machine that we're looking at now came out of Adams on Mercer Island. So just a few miles to the east of us. The panel switch, which is the one behind us, came out of Parkway. There's that office right there. Just kind of gives you an idea of where we are and where these various machines came out of. Each building, because this is a city, so each building had several different machines in it. It wasn't just like one per building. With the exception of Adams. So Parkway had a panel and a number 1 crossbar. And Maine actually had 3 or 4, I think 4 machines in it. I wrote this ages ago. Maine had Maine, Elliott, Seneca, and Mutual offices in it.
Oh, here's officially recommended exchange name.
That's right. So prior to the 1950s, you could choose your own exchange name, but after the 1950s, they published this list of recommended names.
Very nice.
So the Parkway office, for instance, was originally known as Rainier because of the mountains to the south of us. and it was in the Rainier neighborhood. But after 1955, it changed its name to Parkway, which was on the official list of names.
Of course it is, yeah. Parkway, everybody knows that.
But the nice thing is, on your dial, RA is 72, and PA is also 72.
Okay.
So they changed its name, but they could keep the
Didn't
same
make
number.
any difference. That's good.
Yeah.
That's good. Okay. And this one is, oh, this is the back.
This is the completing marker area of the switch. So the marker is really the control, the part of the switch that does all the control. So each time you hear this go, that's one call going through.
Oops. Yeah, ka-chunk.
Each time you hear, so you'll hear this, that's one call being connected. So the marker in that brief second makes all the connections it needs to set up that call.
Okay, yours sounds different. I had an extra ka-chunk in mine.
Yeah.
There it was. That was it. Okay.
So yeah, outgoing
We're good.
calls
We're
sound
good.
different from inter-office calls.
Okay.
So we actually have two markers, this one and this one. They are both doing the same job, it's just this one's older.
Okay.
And they're gonna trade off each call.
Yeah, one uses the next and then the next one uses the other one.
Right.
Yeah.
Normally this office would have had, 7 or 8, something like that. 7 or 8 markers.
Uh-huh.
We just have 2 because we have the smallest.
Okay. There was something I wanted to ask Peter too. Back in the old days, we had a soldering iron that was real thick. It was about that big on the end.
Yeah.
And you would put a little cartridge in. It was like a C battery.
Yeah, you
almost.
go pop.
Yeah, and then you'd pop
Yes.
it.
Yep.
You've got one of those?
Yes, we do.
Those are deluxe.
We got a couple of them.
I've got the handle to one is all I've got. I don't have the end tip and I don't have any of the units that fire up.
Yeah, we don't use them very often. We use the electric plug-in
Yeah,
ones.
of
We don't
course.
want to just, waste them, but we do have them for display purposes. Those feeler gauges.
Yeah. Very nice. With a KS number on it, I hope.
No doubt. Marker programming.
Okay. Where's your little rings where you got to program what the telephone number is?
Oh, that's right over here. So there's 2. This is the number group. This is the one-way translation from a telephone number to a physical line location on the Crossbar switch.
Okay.
So I have the telephone number and I want to know where that is.
Uh-huh.
That's this translation.
Okay.
Okay, now on the other one, it's right over here. This is the diamond ring translator here. This is when
There we go, yeah.
I know the physical location and I want to know the telephone number.
Yeah.
So it's the opposite direction. So when the marker when the translator has a line location, but it wants to know who owns that location, like who's going to get billed for that, that's this.
Yeah.
So this is tied in very, very strongly to the billing aspect of the
And
system.
then you had to wire that every time you got a new number.
That's right. We have 2 of them. We have this one, and then this one, it's all the wires have just been cut all the way across.
Ready to go though.
Yeah.
Now you've got, this is an accounting machine for keeping track of toll, isn't it?
Well, it did. This office, this number 5 Crossbar office, did all of its own accounting. So
Okay.
it used LAMA, which is local automatic message accounting. So this exact machine could have been in a toll office.
Okay.
That would have been, then it would have been CAMA, centralized automatic message accounting. But this in this building, this is for local accounting. So when you place a long distance call from this machine, it punches a record on this paper tape.
Okay. And that's what my wife used to do, is she was the operator and she did that manually.
Right, so this just basically took over that job, and then at 3 a.m. every morning you'd take out the tape and you'd put it in the mail down to the accounting center. So with operators, they did it with, you know, a ticket. You know, they'd manually fill out a ticket.
Wait a minute. We get over there. There we go. Okay.
You know, if with an operator, they'd manually fill out a ticket. They'd write the call details in, and then put it in the calculograph.
Oh yeah, of course.
So I could take, we have index cards instead of tickets.
Uh-huh.
And when the call started, whoops. Ah, there we go. It would punch the clocks into the,
Okay.
it would put the rings of the clocks on the card, right? And then when the call was over, it put the hands in the middle to tell you exactly what the call duration was.
And then you would turn that into your supervisor or something?
Yeah, so different switchboards had different methods. There's one where you'd fold up the card and you'd put it in a little slot and it would shoot down to a, you know, to a collecting room beneath you.
Okay.
I've also seen videos of ones where you clip the card on and just throw it down.
Okay.
But yeah, either way, it was all done manually. And then eventually for like things like the panel office, they came out with message registers, which are these over here.
Just before we go,
Sure.
just how rare are these things?
Oh, you'll see them around every once in a while.
I've got one.
Yeah, I've got one at my house that I use. So then you had, after the calculograph, when automatic switching started being a thing, they had message registers. And each subscriber was assigned their own register. So you had, you know, you were register number 725.
Uh-huh.
And every time you made a billable long distance, or not really long distance, but a billable call, your message register would increment so many clicks. And then they had someone, they'd come over with a camera at the end of every month, and they'd just take pictures of all the groups of registers, develop them, and then...
You know, I had one of those cameras and it was mounted and it would automatically take the picture.
Yeah, we have one over there.
Oh, you do?
Yeah.
Okay.
So later on, they did it automatically. Originally, it was like just a handheld camera.
Uh-huh.
And they called that a peg count. So peg count today. Please be as accurate as you can.
Yes. Because we don't want to miss a single dime.
Right. So, you know, they kept the cabinets locked,
Uh-huh.
of course.
Now, what are these? This
Well,
looks like interrupters.
Well, this frame isn't in operation right now, but you'll see these sequence switches on nearly every frame in the panel switch.
Okay.
It's just that this particular frame isn't running. So this is normally a spinning shaft,
Yeah.
and this shaft spins continuously under motor power. And
Is that the one you were replacing? I was looking at one of the videos and you were down on the bottom replacing.
oh, I was replacing a cork roller.
Okay.
So why don't you come over here and I'll point out what I was doing. I'll talk about these switches as well. So again, this side of the frame is powered off, so you're not going to see them spinning on this side.
Uh-huh.
But these frames in the panel switch are driven by cork rollers. Okay? And that provides the motive power to drive these rods up and down. Now,
Okay.
again, they're not spinning on this side, but they are on the other side because this motor's off. And when I was replacing on that YouTube video, I was replacing one of these rollers that had worn out.
Okay. Now, do you have to make those, or is there a place you can get them?
Well, it turns out I didn't have to replace it at all.
Oh, okay.
What we were going to do is get some custom cork made
Uh-huh.
to the right dimensions and then glue it back on. But it turns out I didn't have to. And it didn't matter anyway because I could not, that roller would not come out. The one I needed to get out would not come out. It was permanently...
And ensconced in there, yeah. Okay.
I needed a bearing puller, but there was no bearing puller of that size that I could find.
Uh-huh. Well, here's our, get a close-up of this unit. And that's your time. Okay. moving right along. I've gotta keep moving before the wife gets too antsy. Oh, there you are. Okay, we're just gonna go further on down. Now, are you the main voice for this place, or does somebody else do that too? I've only seen, whenever I've looked on it on the internet, I've only seen you doing this stuff.
Well, it's because I'm the one that picks up a camera, but I am by no means in charge. We kind of we have sort of a communal way of doing stuff.
Am I getting you here? Yeah, I'm getting you. Okay.
So I just happen to be the one that picks up a camera. That's why I get to be on the videos. But
you're the video person then.
Yeah.
That's good. Let's see here. Here, I can get another little magic trick here if you want to show me some more stuff here. There.
So I'm just pointing this out because this is the maintenance aisle of the number 5 crossbar.
Okay.
And you can't see it on the camera, but over there's the maintenance aisle for the number 1 crossbar. So this is where you would centralize all of the testing and maintenance activity on these machines.
Well, you got a lot of nice room here anyway.
Yep. So when the number 5 crossbar has a problem, it drops one of these cards, which you were mentioning, you saw the video on.
Okay, this is the machine you were playing with.
That's the machine, right.
Excellent.
So this had not been working for years. And I know I talked about it in the video.
Yeah.
So it was quite an ordeal to get it working, but I'm glad I did.
How long did it take you?
I worked on it every day for about 2 weeks.
Yeah.
Because once I start something, I can't stop it until it works.
Yeah.
So. And now it's happily punching cards. I normally keep it busied out because I don't want it to just punch cards needlessly.
Not when you can't find cards. Yeah. Did you ever find a source for cards?
Not yet. I will continue looking, but I've been occupied by other things at the moment. But the nice thing is once you have the card, you can take it and then punch up on this frame the exact information on the card, and then recreate the problem.
Yeah, and then watch it not work.
And then you can go back into the machine and then churn through the problem as many times as you like, which is really nice. It was a lot harder to troubleshoot this machine before we had the ability to punch cards.
Yeah, I would imagine. Let me get rid of my shirt here.
Although I was thinking it might punch a card, but it's being extremely well behaved at the moment.
Now, Peter was saying something about one of these offices, or this office was still in use, is that right?
So this building was, I'm not sure what the context of the conversation was, but this building was a number 5 crossbar office for Boeing.
Oh, okay, okay.
And when Boeing moved their telephone switching into their own building, this was no longer needed for them, which is why we get to be here.
So they sold it to you then, or gave it to you?
No, this was always a telephone company building, but this office is what was called a Centrex.
Yeah.
So there was Centrex on this floor, and what that is essentially a PBX for your business.
There we go.
There we go.
2 of them.
Oh boy, a whole bunch of stuff to look at. 2, 3, 2, 1, 7, 0, 4. Interoffice, callback, number group. No, it got out of the number group. It got the pattern and everything. What are you so angry about? Interesting.
Yeah, that's the thing when you're playing with this, you got to understand how the machine thinks.
Yes, you very much do. So I'm not going to fix that right now, but I'm going to hang on to it for a little later when I will go through it properly. It wasn't the kind of failure I was expecting to see, which is why it surprised me. I forgot what I was saying. Yeah, so this building was a Centrex building. So it was Boeing's PBX. It was phone company owned, and then Boeing paid the phone company to have one of these machines in here, not this one, but one of something very similar, in here just to serve as their internal PBX. And then Boeing said, okay, we're going to move our stuff on site. This floor became empty, and then that's when the museum was able to move in. All of these machines were in service up until the 80s.
Okay.
With the exception of the panel.
That was the reason I left Bell. Was we had I was an engineer, and our group had the task to we had a ESS, and my job was to take the ESS and make it so that it would work as a PBX.
Okay.
And then we were going to sell them to 5 of the big major places around, CDC and Honeywell and I can't remember, Mayo Clinic,
okay,
a couple others. Anyway, we went through all the work of doing it. It took us about 6 months. I went to school on the ESS machine. We got everything up and running. Everything was figured out. We turned it over to the customers, and they said they wanted it.
Huh.
And so we turned the order into AT&T, and they said, no, we're not going to do that because we would not make money on it.
Really?
And that was when I decided that maybe I should be looking for the door.
Maybe. Let's see here. Ah, that's the wrong number.
Now, are you duplicating that bad call?
Yeah, well, I was trying to.
Uh-huh. How'd that work out for you?
It's going through now. What I'm doing is I want to try about 15 or 16 times.
Yeah.
Because it could be the walking circuit has gone bad. And it may only fail a certain number out of those 15 or 16 times. But it seems to be working every time now, so I'll call that a dirty contact.
That's what I found. I found that 99% of the time I could slide in there, kind of get a general area where the problem was, take the covers off the relays and just hose them down.
Yeah.
And everything would be good.
It's working every time now.
There you go.
Okay.
Excellent, excellent.
All fixed.
Moving right along. You're a genius. We did it. Then we got your General Motors diesel power.
This is our power board. Now we get our battery power from downstairs.
Okay.
But it comes up to this board and then it services the rest of the museum. So this particular board was in the Parkway panel office. So we saw the panel way back there. This is the board from that switch. They were able to remove it from the basement and bring it up here.
Yeah, these are quite the setups. We had a power bus that was about 6 inches wide and about a ½ inch thick, and there was a half a dozen of them. The solid copper bars that went all the way through.
So they look.
Yeah, there you go.
This is just a fuse, but that's the bus you're talking about.
Yeah, exactly.
So this bolted.
Let me get homed in on that. There we go.
This is just a fuse that connected 2 of those buses, right?
Uh-huh.
So these holes are for bolts.
And if something bad happens, that chunk of copper in the middle melts.
Yeah, this will melt away. That's the fusible element.
Yeah.
And it's 4,800 amps, so 4,800 amps.
And when that thing lets go, you certainly do know about it.
Yep. And it was behind this thing. Yeah, if you blow that fuse, you're having an extremely bad day. like an extremely, extremely bad day.
Wow.
Now, our service from downstairs is 650 amps, I think, so we would blow that fuse first. So you can see on the meters, this is the AC service from the Seattle City Light. These meters always read a little high. I don't think the AC is actually coming in at higher than 60 hertz, but the meters just read high. And you can see our 48 volt supply is here. And then the ammeter over there is showing what we're drawing. So we're only drawing just a, we're
Not
peaking,
enough to even worry about.
Nothing, yeah, we're peaking at like 80 amps,
Yeah.
which is nothing. Any one of these machines, when they were full size, like busy, could get you up to several hundred amps easily without breaking a sweat. If I turn, I'll be right back. I'm going to turn this machine on as well. Maybe we can get the power needle to jump a little bit more. And then we also have the emergency cell switch. So in a time of great need, when there was more load than the batteries could handle, you could cut in the emergency group to back you up a little bit. Loud noise.
There you go. Very nice.
So you can come down here, hit that button, and you cut it in a whole other bank of batteries. Which they had to do at this board the day JFK was shot.
I would imagine, yeah.
So the load was... The load in the office became so high that the normal bank of batteries was not enough to satisfy all the people who picked up their phones all at once. So the voltage started to sag. And with this battery chemistry, what happens if the voltage starts to sag is you can actually get a polarity inversion on the battery. Let me turn that speaker on. You can get a polarity inversion where chemically what will happen is the cells will invert, and now you have counter EMF pushing back against your normal battery flow, which
and
exacerbates...
then it gets really exciting.
That it exacerbates the problem even